Okay, eighth graders, so we are going to start talking about sedimentary rocks. We just finished up igneous rocks, and now if you were to imagine that piece of igneous rock and it starts going through all of these weird but awesome changes that will eventually turn it into a sedimentary rock. So keep that in mind. And the background very much falls into generally what's going to be happening. So still working with middle school earth science standard 2-1, but by the end of this, you'll be able to identify the 3 different rock types, focusing in on sedimentary rocks, but then also describing the process in which sedimentary rocks are formed. There's quite a few steps, so bear with me. Make sure that you for sure have your whole group notes in front of you, but if you're listening to this, you probably need all your notes in front of you. So I am just going to go through one slide. That is it. It is just going to give you the order in which specific events have to occur in order for a sedimentary rock to actually become a thing. So let's talk about this. So again, if you were to imagine your igneous rock, and I wish I had rocks in my office here at home to be able to be like, imagine this rock, but I don't. So what has to happen are these specific steps. So first of all, this rock needs to be exposed to weathering. Natural sorts of events, wind, sun, rain, water flow, things like that, where it's just kind of chipping away at this rock, weakening it, not breaking it yet, weakening it. Then erosion occurs. This is where the rock actually starts to break. Now, when I'm talking about the rock breaking, yes, I could be talking about a big old boulder that gets like split in half and rolls down a hill sort of thing. But I'm also just talking about chunks and pieces of it coming off. Itty bitty, all the way up to maybe the size of your fist, depending on what size rock we're talking. That is erosion. Through the process of erosion, things are moving, and eventually they get deposited into one location because either A, end of the stream, B, ran into something, can't go any further, or C, the wind died down. Things like that. And we call this deposition, okay? Depositing of something. Once things sit there, just like if you were to probably look at my purse right now, because it's just dawning on me that I brought a Pop-Tart to school this morning. Don't think I ate both of them yet. So if you were to look into my purse, you would see a Pop-Tart. Now, since then, I have taken my wallet in and out. I have added things for Will in it and all this kind of stuff to where that Pop-Tart, which was at the top of my purse, is now at the bottom, probably crunched up into a million pieces. But it's compacting because the older layer gets buried under newer layers, and it kind of, that air, that space is being kind of like pushed out. So that, and then sediment or cementation has to occur. Just as it sounds just like cement, and cement is to bind and hold things together. So now imagine this Pop-Tart in the bottom of my purse, which I really should go double check that. But sorry, Mr. G tried to sneak in here, and then I sent him to go find my purse to make sure that there isn't actually a Pop-Tart in the bottom of it. But cementation. So if you were to pour a little bit of water in my purse, because it just happens, it's snowing outside, snow gets in, moisture, all that fun jazz. And eventually you leave it in there long enough, and it becomes as hard as a rock. Hello, sedimentary rock. Okay, so that sort of thing. So those are basically the 5 steps that lead up to creating a sedimentary rock. Talked about some of the fun layering stuff that happens and all that fun jazz. So bear with me as we move into independent notes. So just be mindful of your champ's expectations as you move through this. If you need anything, just let me know. I'm going to continue on though. So what must happen for a sedimentary rock to form? Well, as I've already kind of talked about it, there needs to be a chemical or physical property of change. Okay, this is where we talk about weathering and erosion. We have to understand the difference though. Weathering is the weakening of a rock. Now you're like, oh, gee, how can a rock be so weak? Da, 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 da. Well, imagine those minerals you were just playing with and how some of them you could just scratch with your finger and it would all fall apart. Okay? Now, imagine North Dakota winds constantly hitting it. And because of where I live, because I still don't have grass, when the wind picks up, it picks up little bits of the sand and the soil and things like that, and it pelts you like little BB guns. Okay? Maybe a little dramatic, but things like that to where it starts to weaken those sturdy rocks. Eventually, you expose it to enough elements through weathering and it begins to erode away or it gets broken into pieces. In the Grand Canyon is a phenomenal example of this, where you have the Colorado River cutting through the middle of this desert, essentially, and weak sandstone, and the water even just rips away at it over a long period of time. Nothing about rocks and changing from one type to another is a quick process. It takes years. So eventually either the rock breaks apart or it dissolves, because sandstone, it's really easily dissolved into water if you've exposed it to enough, things like that. So this must change. So some sort of chemical or physical property of the rock needs to change, and it's through the processes of weathering and then erosion.
Oh my God, there is a Pop-Tart in here.
Shut up! There is not. Really? Mr. G says there is a Pop-Tart in there. I really hope it's today's Pop-Tart.
That's gross, Mr. G.
So, once your rock is weathered and eroded down, all those little bits and pieces eventually have to go somewhere, whether it is through the currents of the stream or river, whether it is through the air, because again, you stand out in my driveway at a good day with the North Dakota wind and my soil is flying across and hitting you in the thigh, it gets down small enough to where it is easily picked up by more gusty winds, things like that. You have to think of just like the bottoms of your shoes. You go walking through somewhere, you can be a part of the like erosion process. Birds eat rocks literally to help digest their food, and it has to go somewhere eventually. So things like that. So after it is dissolved, carried away, wind, water, humans, animals, whatever, eventually there becomes a point where the rock is then deposited, okay? Just as with, say, money. Carry it around in your pocket, you exchange it between you and another person, you get change back, whatever. Eventually it would then be deposited into your bank. Stopping point, okay? That is what we call deposition, where we are dropping the sediment or the itty bits and pieces of rock into one place. Okay, now what happens, obviously, imagine yourself, okay, or go back to my Pop-Tart example. Pop-Tart started at the top of my purse, but as things progressed through my day and my life, it ended up at the bottom. It was now the oldest thing that was deposited, and newer things got deposited on top of it, because that's just the way it works. We'll talk more about that, especially when we start talking about geoscience processes and into geologic time and how we know these things, but it's not something you need to be concerned with now. But what you need to understand is oldest on the bottom, youngest at top, okay? So as these all get deposited, then you start taking into natural like events and things like that. We then get compaction and cementation. So compaction, This is thanks to more and more sediment being deposited on top of the original and just their weight itself pushing down together. This can be thanks to just gravity. Gravity has a force that pushes down on things to where it just gets pushed together, and essentially you're squishing out all of that extra air pocket. Now, the thing about where sediments get deposited is that typically water gets involved some way or another. Snow, rain, stream, river, ocean, okay? Things like that. So then you get the water. Within our water, as we learned, are minerals. Weird. Those minerals seep into these itty bitty cracks if you kind of look here. So you have all the separate little pieces of whatnot, but then they get squished together to where all of them get closer and closer because you have this downward push. Okay. And then eventually you get this water coming through. Oh, that wasn't the color I went for. Get those water coming through and filling in those gaps, but leaving behind in those gaps, you get these mineral deposits, which hold it all together and acts like glue or cement. Sorry, that came out really snarky, not my intention. To where it fills it in together and then you walk away with an actual rock over time. So it holds itself together to where it's not these itty bits and pieces much anymore, but a solid rock. Now, there are 3 different types of sedimentary rocks. After all of these things kind of happen to it, depending generally on what's deposited where or how it's then stuck together or whether organisms and organic material get involved. Okay, so we have clastic or ditral, chemical, and biochemical or organic. Okay, I'm going to talk about what makes each what they are, but again, pictures tell 1,000 words. So clastic, you can imagine it's the bits and pieces. Chemical, something chemically has to change. Biochemical, organic, humans or plants have to be involved. So clastic rocks are if you think sedimentary rocks, this is what you think eventually, because it's easy to see. It is where you get those little bits and pieces of other rocks that you can see just mushed together. The size and the shape of the clastics then help, clasts, by the way, are pieces, help you identify the rock depending on either how gigantic they are, like in this conglomerate at the top, you can see this big piece and this big piece and this big piece, and then everything holding it together is bits of sand and clay and other things that were pushed together. Or if you look at the breccia down here, they're just jaggedy, but they're smallish pieces that are pushed together and again held together through that way. Strata or layering also happens. I have a piece of limestone in the classroom that I'll put up at the front lab station for you to look at. You can see the different layers of different sediment deposits that were stacked on top of each other and eventually cemented together. Coolest things ever. I think strata is gorgeous. So those are clastic rocks where you can see the difference between like the bits and pieces or the sediments of other rocks being formed together into one full rock. Chemical sedimentary rocks is where you get minerals dissolved, many different types of minerals dissolved together, and eventually the water is evaporated or boiled off, kind of depending again what solution it was a part of. So you can make cool things like little pieces of rock salt, chemical limestone, and rock gypsum. We've already talked about halite. We've talked about gypsum. You had to identify them in your mineral boxes. This is where the weird things of like, oh, a mineral can be a rock, but a rock can't be a mineral. These are my minerals that are also rocks. This sort of a thing. So rock salt, halite, that are left together, and it's usually a little bit of different sort of stuff. Chemical limestone is really, really cool. It looks almost like talc, feels a little bit like talc, not as soft as talc. And then rock gypsum, very similar to the pearly fibrous gypsum that you identified in your rock boxes, or mineral boxes, sorry. So yeah, chemical, you don't necessarily see the different minerals coming together. You don't see those different sorts of like sediments together because chemically they're just put under a different process, warm or cold solutions, that then give you this. Biochemical or organic rocks. This is where I tried to throw you off when we talked about minerals. This is where coal fits in. So coal is little bits and pieces of wood, plant material, maybe a little bit of animal something. More than likely not though, just because it hasn't had enough time to actually decompose and come into this yet. But this is where you get sedimentary rocks that are formed together from things that were once living. Often you can actually see the remains. So my super cool, maybe it's just because I'm a dork, I don't know. This top one is phospholiferous limestone. And we call it phospholiferous limestone because if you were to break it down, you see that, oh, let's try a highlighter color that'll actually highlight and not just like block out. So the first part of this is fossil. If you look in this picture, you can kind of see different shells of crustaceans within our oceans that have been cemented together over time. So that's super cool. I'm pretty sure I have a big sample of that as well at school, so make sure, holler at me if you don't see it on my lab station. So that shirt is essentially where you take like the phospholiferous sort of limestone, coal, really compress it sort of a thing. It's made out of more plant material, I believe. And then coal. Coal is coal. So yeah, those are the 3 different types of sedimentary rocks. Those are the 6-step process in order to get a sedimentary rock. And apparently I have a purse to go clean out now because of Pop-Tart. Welcome to my life. So make sure you have your notes complete. After you get your notes done, make sure you come and chat with me. You do have an exit slip for sedimentary rocks. And then tomorrow you will work on the sedimentary rock activities that I've prepared for you. Any questions? Please let me know. If not, awesome. Sweet. Thanks, guys.